A researcher affiliated with Ohio University has recently proposed an intriguing theory regarding the images captured on Mars, suggesting that there could be compelling evidence of potential life forms within these photographs. Dr. William S. Romoser, a distinguished entomologist with an impressive 45 years of expertise in insect studies, has dedicated a considerable amount of time meticulously examining images captured by NASA of the enigmatic Martian terrain. Throughout his extensive analysis, Dr. Romoser asserts the existence of a multitude of intriguing structures resembling insects on the red planet. The distinguished professor, who at the time was specializing in medical entomology at Ohio University, is of the opinion that the visual representations portray exoskeletons and articulated appendages of these living entities. This compelling evidence supports the classification of these life forms as resembling insects. The intricate structures observed in the images strongly suggest their insect-like nature. The individual additionally asserts that certain specimens, as depicted in the images, seem to have rotated towards the camera, suggesting a deliberate orientation for the viewer's perspective. Analysis conducted by Romoser suggests that Mars has sustained life both in the past and currently. He pointed out that the images captured indicate the presence of both fossilized remains and active living organisms on the red planet. He said that the Martian insect-like fauna exhibit a notable variety, showcasing characteristics reminiscent of earthly insects, which are identified as evolved species. This includes notable similarities, such as the presence of wings, the ability to flex wings, agile gliding or flight, and differently structured leg components. He added that the examination of the Martian insect-like creatures reveals a fascinating array of features that parallel those found in insects on Earth, suggesting a level of advancement in their evolutionary development. Utilizing the database accessible from the NASA Jet Propulsion Laboratory, he accessed a plethora of raw images and meticulously created panoramic mosaics. These images were meticulously collected over numerous years from various missions to Mars, with the majority originating from NASA's Curiosity rover. The compilation process involved integrating images captured from different angles and at various times to create detailed and comprehensive panoramic views of the Martian surface. In his investigation, Romoser delved into various aspects including the significant deviation from the environment, the distinct clarity of shapes, symmetry of the body, segmentation of body parts, repetition of forms, skeletal remnants, and scrutiny of forms near each other. This analysis involved a thorough examination of the pronounced contrast with the surroundings, the precise definition of shapes, and the balance in the body structure. He also mentioned that the stance, signs of movement, flying behavior, perceived engagement based on relative placements, and gleaming eyes were indicative of the existence of living entities. Upon identifying and articulating a distinct visual representation of a specific form, Romoser highlighted the significance of this process in aiding the recognition of additional obscure, yet equally valid depictions of the fundamental form. This means that having a precise understanding and depiction of a particular form can greatly assist in discerning and acknowledging other representations that may not be as clear initially, but are still valid interpretations upon further examination. An arthropod can be identified based on possessing an exoskeleton and jointed appendages. In the realm of earthly biology, the presence of 3 distinct body regions, a solitary set of antennae, and a total of 6 legs has long been the hallmark traits utilized to classify an organism as an insect. He said that these characteristics should likewise be valid to identify an organism on Mars as insect-like. In numerous instances captured in the images, a unique and distinguishable pattern of flight behavior was observed among the subjects. These entities bore a striking resemblance to the bumblebees or carpenter bees commonly found on our planet Earth. Upon closer examination, it became evident that their movement in flight displayed characteristics reminiscent of the familiar behaviors exhibited by earthly bees. Romoser purported that among the various images were depictions of bees within their dwelling places, along with fossilized beings bearing a resemblance to a serpent. In an extensive analysis conducted by Romoser, he examined a potential reptile-like fossil in relation to a snake found on Earth. The fossil specimen reveals a detailed glimpse of the snake's anatomical features, including its distinctive beady eyes, 2 front nostrils, and intriguingly, the presence of an insect within its mouth. Throughout a distinguished career spanning 45 years as a professor of entomology at Ohio University and as a co-founder of the Tropical Disease Institute there, Romoser made significant contributions to the field. His expertise extended to spending close to 2 decades conducting research on vector-borne diseases as a visiting scientist at the U.S. Army Medical Research Institute of Infectious Diseases. Between the years 1973 and 1998, he played a pivotal role in the creation and enhancement of 4 editions of the renowned textbook titled The Science of Entomology. Renowned scientist Romoser pointed out that the perceptions surrounding the insect and reptile-like beings he outlined on Mars might shift as our understanding of Martian life advances. He emphasized that despite potential evolution in interpretations, the extensive body of evidence remains highly persuasive. Further exploration and discoveries on Mars have the potential to reshape our views on the nature and existence of these intriguing creatures. The assertion that the existence of more complex multicellular organisms on Mars suggests the existence of essential nutrient and energy supplies, biological processes, interconnected food chains and webs, and the availability of water as crucial components operating within a potentially sustainable yet harsh ecological environment conducive to supporting life was articulated. This statement implies that for life to persist on the Martian surface, a complex interplay of resources, energy flows, ecological interactions, and fundamental elements like water need to be present. He said that upon his observations, he has noted various occurrences that imply the presence of stagnant water or minor water channels exhibiting distinct winding characteristics. These features include the anticipated distortion of small submerged rocks, the visibility of larger rocks protruding at the boundary between air and water, a dampened area along the bank, and a subsequent dry patch extending beyond the moist region. These indications suggest the existence of standing bodies of water, possibly indicating a combination of natural elements, such as meandering streams or stagnant pools. Water presence on Mars has been a subject of multiple reports, with instances of surface water being identified through the sophisticated instruments aboard missions, such as Viking, Pathfinder, Phoenix, and Curiosity. In an ambitious scientific endeavor, NASA has scheduled the launch of a cutting-edge rover mission to Mars in the year 2020. The primary objective of this groundbreaking mission is to meticulously explore the enigmatic red planet in search of compelling evidence indicating the existence of life forms. The region under discussion harbored a significant lake approximately 3.5 billion years ago, which has left behind a plethora of carbonates and hydrated silica as remnants. Carbonates present within the inner rim of the crater have displayed remarkable resilience, as evidenced by their preservation in Earth's fossils over extended periods spanning billions of years. Furthermore, explorations in the Delta region have unveiled the presence of hydrated silica, renowned for its capacity to effectively safeguard biosignatures. The Mars 2020 mission, as communicated by NASA, is dedicated exclusively to the field of astrobiology, which revolves around the exploration of life across the vast expanse of the universe. Advocates supporting this hypothesis assert that specific formations observed on the Martian terrain exhibit a remarkable similarity to insects found on Earth, displaying characteristics like distinct body segments and limb-resembling protrusions. On the opposing end, skeptics counter these claims by attributing the perceived insect shapes to geological phenomena such as erosion, wind action, and sedimentary processes. This faction argues that these formations lack conclusive evidence of organic composition or biological origins, underscoring the ongoing dispute without a definitive resolution in sight. The discourse between proponents and skeptics adds layers of complexity to the exploration of potential extraterrestrial life on the red planet, fueling further investigations and discussions within the scientific community. So, what do you make of these mysterious Mars photographs? Be sure to leave your questions and answers in the comments section below and help us to grow this community while working to solve these unexplained mysteries. Thank you for watching, and don't forget to subscribe for more videos.